Go. So today we're looking at Venn diagrams. We're looking at unions and intersections. So for example, if I've got the set, this represents that we've got a set of numbers, and A is everything 3, 6, 9, 12, 15 and 18. So there is, I guess we can say that 6 is an element of A. Why? Because 6 is in the set A. Can you see that? Now, so an important symbol is this thing here, the element. 6 is an element of A. That's what it means. Now, the number of A. What is the number of things, or number of elements in this set A? What's the number? Well, we've got 1, 2, 3, 4, 5, 6. So the number of A is 6. Okay? However, don't be confused. 6 is an element of A, means that there's actually, we could also say that 9 is an element of A. Okay? Because 9 is a value inside the set A. Alright, so a null or empty set can be represented by a 0 with a line through it. Okay? Just means that there's nothing in it. It's a bit pointless though, to be honest. Why look at sets with has nothing in it? Okay? But it's just some terminology. Now, here's some things that you need to see. A, I would like you to think about this as it starts with I. When two things cross, what's the word? Now, can someone put their hand up and tell me, Christos, when I come to you, what is that word?
Intersect.
Intersect or intersection. Yeah? All right, so the intersection is A. This is A intersection B here. Okay, and by representing that on the Venn diagram, can I get a show of hands to those people who have seen Venn diagrams before? All of you, thank you. We've actually done all this. Now, then you've got the intersection and then you've got the union. The union means A, if you like, we could say this in English, A or B, which means that we're happy with A, all of A, also where it intersects with B, and we're also happy with B as well. Can you see that? However, A intersection B is only when it's A and B. So if you think about this in terms of English, this is what? If this is A or B, what's A intersection B? A and B. Thank you. Now, two sets A and B are mutually exclusive if they have no common elements. In other words, I'm not sure this A union B, isn't that supposed to be A intersection B? I believe it is. That's a mistake. Okay, this is a mistake. A intersection B, which is where they cross, is equal to, it's a null set. Okay, it means that there is no intersection. Okay, no intersection. All right, now Venn diagrams and two-way tables. Let's have a think about it. We've got 28 students that like maths and like English. We can see here that we've got a union maths and English. So where does my 28 go? Can someone put up their hand? Can someone put up their hand and tell me where the 28 goes? I'm going to come over here and I'm going to say, here you go, Eloise, tell us.
In the middle.
And it goes in the middle, which is A. Yeah, you can actually, why don't you draw it? Can you write where 28 goes? Awesome. Well done. Now, it says here that there's 33 people that like maths, so therefore they don't like English. So Amelia, how many people don't like English but they like maths?
33.
Well, we've got 33 in total that like maths. However, 28 of those don't like English. So 28 plus something equals 33.
5.
So 5. Thank you very much. So you can see there that we can start filling in the gaps here. And that's what I'm going to get you guys to eventually do. You don't have to copy all this down though. What about those people that don't like maths? Well, if you think about it, there are 61 people that like English. So therefore, how many don't like maths? 30? 33, isn't it? 33 plus 28 has to equal 61. And this is 39. 39 don't like English. Okay? Now, Of course, this has to add to 100. So how many don't like maths? 67. That's not very, very good. Clearly that's bad. Do you like maths? Do we like maths? Yes, we do, don't we? Okay, now let's look at this terminology here. What is this saying? P of M, what is that asking for? Can someone put their hand up and tell me? What is P of M asking us for? Come on, I want...
Is it the number of elements in that?
No. P starts for what starting with P?
Probability.
Say that to me, Aiden.
Oh, probability.
Probability. Okay, so what we want is we want to find the probability of M. Now, what is the probability of M? First of all, let's fill out in our Venn diagram. 28 like maths, but they also like English. And 5 don't like English. So we've got 5 in here. Let's fill it out. What about English? Those people that like English, but they do not like maths. There's 33. Okay?
And then you put the 34 on the outside.
And then the total has to add up to 100. So 38, 61, 33, 61, 66. There's 34 that don't like maths or don't like English. So, what's the probability? Now this is the power of a Venn diagram. Matt, you all right? Do you want to go sit outside and do it? Go move your table outside. Shh. Probability of mass. This video is still going, by the way. Probability of mass then is now probability is going to be. Can it be greater than 1? Can a probability be greater than 1? Can you talk into the microphone and tell us why it can't be?
No, because... No.
Why?
Because you can't have... Yeah.
It's just not
Well,
possible.
what is the probability of 1?
100%.
It's 100% certain, isn't it? So you can't get more than certain. And you can't, and 0 is absolutely impossible. Okay? Never happens. Probability of maths then is we've got 33 people that like maths out of what? 100. That's the probability of maths. That people like maths. What about the probability of people that don't like English? How many people don't like English? You got 5 plus 34, which is what? 39 out of 100. Thank you, ladies and gentlemen. And if you like, we could do these in percentages. If you like, that's 33%, because percent means out of 100. This is equal to 39%. Now, or we could even say 0.33. Remember that all 3 of these things are viable options. Okay? They all represent the same thing. In a test, if you had 33% rather than 33 over 100, I'd probably give you, unless I asked you for a percentage, then I'll probably give you the marks. Okay? No matter what. That's 0.39. Now, what about the probability of English intersected with maths? What's the probability of that? 28%. Awesome. Are we okay with this stuff so far? Yes, I heard yes. Awesome. Now, a number is chosen from a set of positive integers from 1 to 10 inclusive. A is the set of odd numbers. So therefore, what are the elements of A, please? From 1 to 10, what are the elements of A if A is the set of odd numbers? 1, 3, 5, 7 and 9, yes? There's 5 of them. What about B? B is the set of prime numbers. Prime numbers is, it's not 1, 2, 3, 5. It's only factors of itself and 1. 2, 3, 5. 2, 3, 5, 7. It's between 1 and 10, mister. Now, what about A intersection B? What are the elements of A intersection B? Where is the common thingy here? Thank you. Awesomeness. Okay. So, A intersection B is 3, 5 and 7. What about A and B? Or A and B? Yeah, it's all of them. But the thing is, they don't write them out a second time. You can say 1, 2, 3, 5, 7 and 9. 1, 2, 3, 5, 7 and 9. What's not A? What's not A? Well, what about the elements, all the elements of 1 to 10 inclusive? So what's not A? 2, 4, 6, 8, 10. Okay, 2, 4, 6, 8, and 10. And the number of A. How many numbers are 5? Thank you. And B only. B only is 3, 5, and 7. No, isn't it just 2? 2? So there's only, so B only, there is number 2 is, I guess, what we're looking at. All right, so therefore, what's the probability of A? We've got 1, 2, 3, 4, 5 out of 10. Probability is 5 out of a 10 or a half. Probability of A union B, we've got 6 out of 10, which of course you would simplify, wouldn't you? Let me go, let me just, my thing's packed up a bit. Okay, I'm going to pause. It works. Okay, so A union B is 6 out of 10, which we can simplify as 3/5 or what? 60%, yeah? And the probability of A intersection B is 3 out of 10, which is equal to 30%. Okay, now the Venn diagram shows the distribution of elements in the two sets. All right, look, we've been through this, but remember that if I was to ask you what is the intersection of not A and B, what is, if I had over here A, B, can someone just tell me what is the intersection of not A and B? Matt? All right, so what's not A? Well, first of all, this is all A. So if I shade all of this, this is A. Okay? So it's certainly not that. What is not A that intersects with B? 6. So the answer of the number of elements which is not A that intersects with B is 6. It's not this 3 here because that's not inside the set of B. Okay? So that is equal to 6. Apart from the other stuff, what is the probability? Be careful though. N stands for number. All right? How many elements are there? P stands for probability. We need it as percentage. There's no way you can have something greater than 1, less than 0. So what is the probability of A intersection not B? 2. Thank you. Is it probability? Probability is the number of favourable outcomes. This was 8A, ladies and gentlemen. Favourable outcomes over the number of outcomes. Okay, how many are favourable? 2. 2 are favourable. So we've got the probability is 2 out of what? 12, yes. Which is equal to 1 over 6. So the probability of A intersection not B is 1 over 6. Are there any questions so far? I'm going to stop that video.